Hello to everybody. Apologies for not being there in person. Unfortunately, my flight was cancelled, so I'm a bit jealous that you're all in the south of France and I'm here stuck in London. But I guess to start, my name's Fearghus Foyle, and I'm managing director of an Irish company, GeoAerospace. And today, I just want to run through. It's very much an R&D project that we've been working on over the past few months. It's about using drones for quite a novel use case, looking at whether we can quantify the amount of biomass above ground in hedgerows across Ireland. So obviously with climate change and European trading scheme credits, governments are looking at trying to understand how the landscape evolves over time and how much carbon is stored above ground. Obviously, there's underground or below ground biomass as well, but what we're interested here today is in above ground biomass. You can see what I'm talking about is the hedgerow on the left. So in essence, we're trying to measure how much timber and how much material is in that hedgerow, which is quite complex because it's quite dense. You can see some of YellowScan's screen in the middle. And then on the right, because this is, I guess, it's a government-led project from an agency, GeoAerospace, which is the farming agency in Ireland. I was asked to speak to Prince Charles as well about the same topic. I think I bored him to death, though, so hopefully I don't do the same to you guys today. The drone you can see is the Quantum Systems Tron, and on board that is the LiDAR. I believe Martin Harecomer is with you today as well, so hello to Martin. He trained us on the Quantum Systems drone, which is a great platform in tandem with the YellowScan Surveyor Ultra, which is what we used on this project. And then you can see some outputs in the bottom left there. So I guess I'll just summarize what I'll talk about today. I'll give you a bit of background about GeoAerospace, our company, and then the project itself and what that entails. I'll discuss the value of hedgerows and why they're important to Irish agriculture and the Irish government. And then I'll talk about how biomass is measured and why LiDAR might help that. And then our approach to this project, and then in the wider context, how LiDAR has been used in the agricultural sector across Ireland. And I guess it'll be the same globally, but this is quite a bespoke use case for LiDAR in the context of Irish agriculture. I guess GeoAerospace, for those of you that don't know, many won't obviously, we're an Irish company, geospatial information services company. So we have we use spaceborne data. We have our own aircraft, you can see there, and then we have a suite of drones. So we collect, process, and analyze geospatial data, and we're sector agnostic. So we'll work across utilities to agriculture to maritime, and then a lot of the work we do is in the R&D space. All our data then is in our own cloud platform. So we provide geospatial data as a service, I would say. So on our platform, obviously you come on and you book a survey, we carry out that survey, and then that's shared with your team. It's pretty standard solution. But back to this project, it's called the Signpost Project. You can see the sites. There's about over 100 sites around Ireland, and these are all farms. They're in the region of sort of 100 hectares, so they're a nice size to map with drones. Some go up to 1,000 hectares, but the majority would be in and around 100 hectares in size. And there's different types of farms, so there's dairy farms, grass, crop, a whole host of different types of farms. Our client, GeoAerospace, is the Irish the Agriculture and Food Development Authority in Ireland, so it's a semi-state agency. The client brief on this project was to go and collect high-density LiDAR over a series of selected farms across Ireland in different times of the year. The challenge, obviously, is to try and measure and quantify the size, the density, and the volume of hedgerows using LiDAR. And then with those measurements, can we convert them into biomass and thus their carbon sequestration potential? And by carbon sequestration, it's the carbon stored in those hedgerows. I should say it's not easy, but I'll quickly play this video, which will give you an idea of the sort of the scale of the project, or the scale of the sites we're working on. These are, sorry, this will quickly go through, 50 hectare plots, essentially, the one we're looking at here. We're collecting LiDAR, the YellowScan Surveyor Ultra. We're using a P1 DJI RGB camera in addition on a second drone, and then we're also collecting multispectral data. As you can see, the hedgerows and what we're trying to quantify is these hedgerows you see throughout the farm. These are common. They're a common feature across Irish landscapes, and they have the potential to store a lot of carbon over the years. So it's about trying to understand how much carbon can be stored in these landscape features. Obviously, there's other additional services that you can gather once you collect LiDAR. So it's not just about the carbon storage piece, which is quite complex, but you have the ability to carry out overland flow assessments, 3D mapping, design for access roads, drainage, and built infrastructure, obviously. So there's a whole host of services on the back of this one application for carbon sequestration, which is what we're trying to do in this project. But I'll quickly give you a quick summary. Why are hedgerows important? Hedgerows, obviously, they're a prominent feature, as I said, in the Irish landscape. They have an important biodiversity role, and from an agricultural management point of view and a carbon sequestration, they're very important. Ireland, to give you an idea of the scale of the problem, we have almost 1 million kilometres of hedgerows in Ireland. So every field has a boundary that's defined often by hedgerows. That's 4% of the landmass in Ireland. So it's a huge amount of land we're talking about. And with that comes the potential to sequester, which is to store carbon, almost 3 tons per hectare. So it's a significant amount of carbon that these hedgerows have the potential to store. And they're not a compulsory part of the European trading scheme, but they're a voluntary. They could be seen as a voluntary component of carbon credit schemes. So the government is interested in understanding how much carbon can be stored. And I guess to do that, you need reliable, accurate data, which LiDAR obviously offers. And then over time, you repeat these surveys. So you get a baseline data set, which is what we've done. And then over time, you try and measure that change, and you measure the amount of biomass that increases, and those are converted to carbon credits. I will always say it's not straightforward, but hopefully this presentation gives you an idea of the size of the problem and what we're trying to do to solve it. So I guess what has been measured? Biomass is living biomass, dead wood, and soil. And there's above ground and there's below ground. The diagram on the right, I guess, summarizes quite well. You'll see the bit we're interested in is that hedge on top. So everything above ground, that living woody structure that's above ground that can be measured. But it comes with a whole host of problems and challenges. And then below ground biomass is often done by soil sampling. There's also destructive methods of sampling, which is cutting down the trees, hedgerows, and measuring them in situ. But remote sensing offers a sort of a scalable solution, which we think is probably there's a better opportunity to scale and understand how much biomass is present in hedgerows across the country at a national scale, whereas in situ measurements obviously are a lot more time consuming. And why do we measure it? I guess it's important from a carbon to quantify carbon stock changes for national greenhouse gas reporting and land use change and forestry accounting. As I said, it's measured by in situ measurements, soil sampling, and then now remote sensing. That's another example of a hedgerow in the bottom right. They're quite varied, so you have different. Here's a classic example of multiple different types. So we're never talking about the same thing. That's what's part of the challenge, is you're always dealing with different hedgerow structures. They have different species of trees, different ages of trees. The tree stems, branch, leaf structure are always different. And then it's whether you do the survey with leaf on, leaf off. And then underneath these hedgerows, there's often walls, ditches. So they're just really complex structures to try and to measure. But LiDAR does offer an excellent solution in trying to quantify that 3D measurement. And then you can see the same image on the right. And I guess it's just to highlight the only piece we're talking about here is the above ground. Obviously, we can't deal with below ground at the moment. So it's the above ground measurement we're interested in. And above ground biomass is living vegetation above the soil, including stem, stump, branches, bark, seeds, and foliage. So it's that sort of physical timber or woody structure, leaf structure. There is destructive methods of biomass measurement, which are time-consuming, resource-consuming, they're strenuous and expensive, and they're hard to scale. That's where someone comes in and cuts down the woody structure and measures it physically. You can do it by climbing, but these are obviously quite time-consuming and expensive. LiDAR obviously is non-destructive and it's very accurate. I guess the challenge comes when you're dealing with such unstructured trees, whereas in the forest you'll often have a well-defined trunks and they're easier to measure, whereas a hedgerow is often quite light and quite woody in structure, so it can be really challenging to get that accurate 3D measurement. But yes, remote sensing, I guess, is a potential solution to gather information at scale. So as I said, measurement of hedgerows using remote sensing data is extremely complex due to the density of canopy, whereas with LiDAR or with RGB, you can build a DSM, a digital surface model of the hedgerow, but you obviously can't understand what's beneath the canopy. If you can see in the bottom left, that structure, it's quite difficult to see and to visually see through that canopy, whereas LiDAR obviously will give you that penetration, and the YellowScan Surveyor Ultra is what we've been using, has proven to get really good penetration through canopy. You can see that's from one of our scans of the forest, of the hedgerow. The top right there give you a good idea of the kind of penetration through canopy that we're achieving with the YellowScan Surveyor Ultra. So it is different to forestry scans where you have that sort of commercial forestry structure you can see in the bottom. These are well-defined trunks that are probably easier to measure than I would say that woody light structure of a hedgerow. I guess the challenge then is to do the survey when there's leaf on and leaf off. The results are completely different, obviously. And then, as I said, the LiDAR obviously provides these really rich point clouds that penetrate through the surface of the trees, or through the surface of the ground beneath the trees. And you get that resolution that you require to measure the stems and the individual trunks. So I guess our approach to this, we have numerous sites across the country. Our approach, like all our operations, I guess, I think one of the speakers alluded to earlier, UGCS is our flight planning tool of choice. It's brilliant for terrain following and mapping in general, and it's very user friendly. So we use it, I think, nearly on every operation. For these sites, we've used DJI M300, again, great platform. The YellowScan Surveyor Ultra on one, DJI P145 megapixel sensor on another, and then an Alta multispectral. So we're trying to blend these different data sets together to understand exactly which offers the most potential. So it's sort of multimodal sort of sensors. Data processing, we use obviously YellowScan's own cloud station, Bentley software, and then we have a series of custom scripts, GDAL and PDAL. And I guess that's our main focus for this project, was the flight planning, data acquisition and data processing. And then with GeoAerospace, that's the agency, they're looking more at the analysis piece and developing bespoke tools for quantifying or taking our 3D measurement and quantifying the biomass. So I guess the image on the right, you'd be familiar with UGCS, as I said. That's our flight planning tool. We use terrain following all the time. Often these sites are undulating or they're hilly, so we'll use digital elevation models input into the flight planner. Our altitude is normally 80 meters, 50% overlap, a swath width of 40 meters, and a 60-degree field of view, so 30 degree either side of nadir. We have numerous scenarios that we flew in winter and summer to try and understand what's the best solution. So when I say leaf on, leaf off, is obviously winter and summer, or sorry, other way around, summer and winter. Multiple sites across Ireland. There's about 100 we've covered. I don't know how many sites at the moment, quite a lot. And we're doing temporarily as well. In addition, we're not just doing one flight, we're doing them over time. On site between the three drones, you can see in the top right, LiDAR, multispectral and RGB, typically 1 to 2 hours. The dream scenario obviously is to integrate all these sensors into one platform, so we're not flying 3 drones at once, we're flying one drone with 3 sensors. But that's coming closer, I hope. The density we're achieving at that sort of 80-meter height, I think, is somewhere, I'll have to confirm this, but this is what I believe it to be, 120 to 150 points per square meter. So really rich, dense point clouds. 3 returns also gives us good penetration through the canopy. We fly, obviously, with parachutes. We're all specific category licensed operators, so we generally have flight terminations, or always have flight termination systems and parachutes on board. You can see in the image on the top left. In terms of processing, once we collect the data, we process the raw point cloud, the raw LiDAR. They classify the point cloud, produce a digital surface model, digital terrain model, and then that point cloud is filtered to ground and mid-height vegetation. And you can see in the top right, you're left with that hedgerow or woodland feature extraction. And then we try and create a volume measurement by draping a mesh over the hedgerow. But the ultimate aim really is that mesh could be done with RGB, essentially, is what we want to do, is try and get down and measure the biomass within each branch. So to try and measure the structure of each individual stem and branch within the hedgerow, which is, you can see in this top left image under data processing, we're trying to sort of measure the individual branches, which is obviously a huge, significant challenge. I guess it's important to say, as I've alluded to already, LiDAR does not measure biomass. It just gives really accurate 3D models of the structure that you're flying over and its physical components. So combined with RGB, it has the potential to enable stratification of the hedgerow into species, age, size, crown, height, etc. And then there's potential to use a biomass expansion factor, which enables a measured stem, so a smaller part of the structure, to be converted to a whole tree volume. And this is ongoing. This isn't a solution we've actually completed just yet, so it's still a work in progress. And that's so these allometric equations that convert those 3D dimensions of the hedgerow to biomass are what probably will be used as this project moves forward. So at the moment, GeoAerospace, the government agency, are creating those models for Irish hedgerows. So that's, I guess, our primary focus was to get out and collect all this data, process all the LiDAR, and hand it across to GeoAerospace. So the next steps are these flights where we'll do repeated flights to try and measure change over time. We're going to target particular species because each hedgerow has multiple. It's not like a commercial forest where it's one tree species. These have multiple species within a single hedgerow, different age groups. So it is complex, and let's try and get a better understanding and try and obtain high definition tree, stem, branch information. So to model these stems into volumes and then calculate a BEF, and then in tandem, where you have to do some destructive measurement where you fell some of the trees or fell some of the hedgerows and physically measure and compare that back to the measurements from the LiDAR data to see if they're close and to verify what we've done thus far. And then this number hopefully could be applied to similar plots or similar hedgerows in order to scale the measurement mechanism rather than the destructive method that I mentioned earlier. I guess what's important to note is there's additional, when we go and do this work, it's all about sort of the additional services that we can offer our customers. So obviously you can reconstruct the entire landscape in 3D. So to measure and map the slope, aspect, and elevation, which helps crop yield on farms. So giving this LiDAR data to farmers is really important as part of this project to help them increase their crop yield. There's obviously, you can improve drainage methods, overland flow assessments, and ultimately it helps with sort of design, site layout for access tracks and routing, and then built infrastructure as well from a planning point of view for the future. And I guess I should reiterate, this project is very much ongoing, and it will continue, I think, for another year or so until the methods and methodologies are refined. But a lot of the data collection component is completed, and I think it's now about analyzing all that data that we've collected. But there's been some really positive feedback on the quality of YellowScan's LiDAR, the quality of the point cloud, and the penetration through canopy, which is the key component here. So I'm excited to hear that YellowScan launched another sensor this morning. So we'll have to take a look at that. I'm sure it's above and beyond what we have already. So But yes, hopefully that gives you an idea of a novel R&D use case that we're currently working on. But I appreciate if anyone had any questions, I'm sure I can try and answer them.